Hi everybody, we are back to a new section in our packet. We are going to be talking about exponent properties involving quotients, which is division. So we are in that same packet, which is Unit 9, Chapter 10. We're still in Packet 1, and you should be on page 34. Okay, I'll write that at the top in case you can't see that at the bottom. Page 34, okay? Exponent properties involving quotients, dividing exponential expressions with, we're going to say, the same base, okay? So let's just look at a couple of examples here. I'm not going to do the whole chart. We've got 7 to the 9th. Let's just move this down so you can see a little better. 7 to the 9th over 7 to the 3rd, okay? First, we're going to talk about expanded form, and that's as a repeated multiplication, okay? So we have 9 sevens. So 7 times 7, we're going to write them all out. 6, 7, 8, 9. That should be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 7 to the 3rd. 7 times 7 times 7. Okay? And if you notice, some of these can be simplified, right? And then we are left with how many? 1, 2, 3, 4, 5, 6 of them. We have 6 sevens. So now we're going to talk about exponential form, which is simplest form. So we have 7 as our base, and it's raised to the 6th power, okay? And then when we talk about standard form, that's when we actually evaluate the numerical base. So it's 7 to the 6th, and I don't expect you to know that. You would put that in your calculators, and you would get 117,649, okay? Let's try another one, okay? I like this problem because we have both a coefficient and then we have the variable. So we have 20 over 5. We're not going to do anything different with that. We just treat it the way we always would. And then we have 5 x's on top. 1, 2, 3, 4, 5 over 3 x's on the bottom. X times x times x. We can do some simplification. Those simplify out. 20 divided by 5. We'll do that in a second. How many x's are we left with? 2. So that's going to be x squared. And 20 divided by 5 is 4. So that's 4x squared. And here, exponential and standard form are actually the same thing. Okay? So you should get the idea of what we're doing here. Okay? If you can see, there's a pattern that's happening here. Okay? When you have the same base raised to an x power and its division or quotient, you can subtract, okay? So I could have taken 9 minus 3 and I'd get 7 to the 6th power. I could have taken 5 minus 3 and gotten x to the 2nd power, okay? So I really like this next problem also. I'm going to go down here. If we have 13, let's see, it would help if you could see the problem. 13 to the 6th times 13 to the 8th over 13 to the 9th, okay? Now, you could write out 6 13s and then 8 13s and then over 9 13s, but I'm going to show you an easier way. Remember, when we multiply, we add exponents, and when we have a quotient, we subtract. So we're going to do 13 to the 6th plus 8 over 13 to the 9th. 6 plus 8 is 14, so we've got 13 to the 13 to the 14th, okay, over 13 to the 9, and then I'm going to subtract. Equals 13 to the 14 minus 9, which equals 13 to the 5th. And that is your final answer, okay? 13 to the 5th. And then we would put that in our calculator, and we'd get some crazy number. Let's see, what is it? 371,293. Okay, and that's just from putting it in your calculator. The other thing I want you to take away from this, if you look at this problem right here, j to the 8th over j to the 8th. Okay, well, if you look at this, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 6, 7, 8. They all cancel, right? And you're left with 0. So j to the 0. Okay, so what I want you to take away from that is just a simple rule, is that any number, let's see, that's supposed to be a y, any number to the 0 power equals 1. And you put it in your calculator. It can be 1,000 to the 0 power. It could be 1 to the 0 power. It could be 10 to the 0 power. Your answer is always going to be 1. Put it in your calculator if you don't believe me and test that out. Okay, let's go ahead and let's flip the page. We are now on page 35. Okay, and we are talking about quotient of powers property. When dividing terms with powers, so say we have a to the m over a to the n, you can see the bases are the same, so we can subtract exponents. Okay, a to the m minus n. If and only if the bases are the same, again, this only works when the bases are the same, then we may subtract the exponents to get simplified answers, okay? So let's just do a few of these. Negative 8 to the 8th over negative 8 to the 3rd. We're going to take negative 8 to the 8 minus 3. We're going to get negative 8 to the 5th. We have a negative raised to an odd power, so I know my answer is going to be negative. And 8 to the 5th is 32,768. Just putting that in my calculator, okay? Here, let's skip over to this one. P to the 7th over P to the 6th. That's P to the 7 minus 6, which is P to the 1st. P to the 1st is just P, okay? So all we're doing here is subtracting. Look at this one right here. That's the same as being over 1. So you can take 1 times y to the 21st equals y to the 21st. Y to the 8 times 1 is y to the 8th. I'm going to do y to the 21 minus 8, which is going to give me y to the 13th. Okay, so all we're doing here is subtracting exponents when we have the same base raised to a power. Okay, I like this one because it mixes some things up. We've got 4 to the 2nd times 4 to the 8th over 4 to the 4th. Well, I can do 4 to the 2 plus 8, because remember when we multiply the exponents with the same base, we can add. 8 plus 2 is 10. So we've got 4 to the 10th over 4 to the 4th. I'm going to subtract 10 minus 4, and I'm going to get 10 to the 6th, which if you put that in your calculator, it should be 4,096. Oh, it would help if I got the right base. Let's try that again. 4 to the 6th equals 4,096. Okay? Now, keep in mind, coefficients are still treated the same way, okay? So I actually separate those out. 16 over 64, p to the 5th over p. We've got q to the 12th over q to the 3rd. And we've got r to the 17th over r to the 5th. I'm just subtracting. Okay, 16 over 64. Well, that simplifies. 64 is divisible by 16. That becomes 1/4. So I'm going to leave that the way it is. Okay. Then I've got p to the 5 minus 1, q to the 12 minus 3, and r to the 17 minus 5, which is going to give me, let's see, what is that? 5 minus, that's supposed to be 1. That's going to give me p to the 4th, q to the 9th, r to the 12th, all over 4, okay? So that's what we do when we're talking about the quotient of power properties. If you want to flip over to page 38, let's see. Oh, sorry, I lied, page 36, okay? We are going to look here at something else, and it's called the power of a quotient, okay? M to the 5th, n to the 5th. All we're going to do is distribute that 5 to both top and bottom. We have m to the 5th over n to the 5th. Different bases, so we can't do anything else. Same here, we've got 3 to the 3rd over p to the 3rd. Okay, that can be simplified. 3 to the 3rd, 3 times 3 times 3 is 27 over p to the 3rd. Okay, on this one, we've got the same bases, so we can do 5 to the 6th plus 4. Okay, that's 5 to the 10th over 5 to the 2nd. 10 minus 2 is 8. So 5 to the 10 minus 2 is 5 to the 8th. Okay? And if you put that in your calculators, you get, I think, 390,625. Okay? I like E because that negative is inside the parentheses, so the 2 attaches to it. So we've got negative 8 to the 2nd power, y to the 2nd power. Negative 8 squared is 64 over y squared. Okay? This one we're going to distribute again. And remember, you distribute it to everything. So we're going to have x, 2 times 2 is 4. So 2 times 2, remember we multiply when it's power raised to a power, over 4 to the second, y to the second. That's going to give us x to the fourth, 16y squared. Okay, I know I'm throwing a lot of information at you. Just remember, when dividing, powers or exponents do not divide the base. For example, 2 to the 7th over 2 to the 4th is 2 to the 7 minus 4, which is going to give you 2 to the 3rd, not 1 to the 3rd. Okay? Power of a quotient property, if a is a real number and m and n are positive integers, and we just did this, we're going to say a over b to the m is a to the m over b to the m. Okay? We're in the home stretch here. Let's look at page 37. Okay? Okay. Remember, often simplify the given base first will make simplifying much easier. So let's just do a few of these. Let's look at C, for example. 15 squared times 15 to the 9th over 15 to the 6th. Okay? That's going to give me 15 to the 2 plus 9 over 15 to the 6th. That's going to give me 15 to the 11th over 15 to the 6th. Okay, remember, base is the same. We have the quotient rule, so we're going to subtract exponents. 15 to the 11 minus 6, which equals 15 to the 5th power, which is going to give you, if you put it in your calculator, 159,375. Okay? Let's go down to letter F. Okay, we have the distributive property here. I'm just going to distribute to everything inside those parentheses. So I've got 3 to the 3rd, x to the, remember, power raised to a power, you multiply, 5 times 3, over 10 to the 3rd, y to the 2 times 3. Okay, that's going to give me 3 to the 3rd, x to the 15th, over 10 to the 3rd, y to the 6th. I can't do anything with these because they have different bases, but I can go ahead and multiply that out. 3 to the 3rd is 27. 10 to the 3rd is 1,000. I've got x to the 15th on top and y to the 6th on the bottom. Okay? Looking at 39, just one more quick one, and then we're going to look at one more thing, or, well, you'll see, one more topic, I should say. Okay, that 2 distributes to everything inside the parentheses. So here and here, it's just on top. So we've got 15 v to the 3 times 2, w to the 2 over 3v squared. Okay, that's going to give me 15 v to the 6th, w to the 2nd over 3v squared. And you can see right here, got the same base, so I can subtract. I'm going to do a 6 minus 2, which is 4. So I've got 15 over 3, v to the 4th, w to the 2nd. And you can see simplification here. You treat your coefficients just like you always do. 15 divided by 3 is 5. So you've got 5 v to the 4th, w to the 2nd. Okay? And finally, if you turn to page 38, I just want to show you one more thing. Okay? Let's flip down to I or L and M. Okay? Here it says to write an equation to solve the missing exponent. Okay? I'm just going to show you this briefly. See how you have the same base of 7? Okay? Just do the exponents like you normally would with your rules. 7 to the x, 7 to the 2. Well, that's going to be x plus 2. Over 4 is going to be minus 4. And what does that equal? Your exponent of 6. I know I just blew some of your minds. X minus 2 equals 6. Add 2, and you get x equals 8. If you were to plug 8 back in here, 7 to the 8th times 7 to the 2nd is 7 to the 10th. 7 to the 10th over 7 to the 4th, 7 to the 6th. It works, okay? Let's do another one. An exponent raised to an exponent is going to be 2x. Divide, so we subtract, equals 36. See, we had the same base. So I'm going to add 6. I'm going to get 2x equals 42. Divide by 2. x equals 21. And I think that's right at the 15-minute mark. That is plenty for today.